opportunities into tech, or whether it's that they're just not here, in which case work out why they're not here, why they're only in your workplace. Do you not enjoy this? Explain why it's so fun. And if there are barriers, why people aren't able to get here. Maybe the time is not so good and a lunchtime thing in your company would work well, whatever it is, see what you can do. However, I do have one actual concrete proposal which makes a change. Many of you have name badges on. I have filled mine in slightly differently to, I think, everyone else in that I've put my preferred pronouns on. I believe, and I could be entirely wrong about this, I believe that within the transgender and non-binary communities, this makes it more inclusive because they feel, well, for a start, that people understand that pronouns are a thing and that you shouldn't make assumptions, and that they can then express themselves so that even if you might otherwise greet them and say, that guy over there, well, if she's got she, her as a preferred pronoun, then you say either that woman over there or she's done this, etc. I will need to check this with my daughter, who is herself a transgender young woman, whether this is reasonable advice, but next time you're meeting here, doesn't matter if no one is trans here, getting into the habit of being inclusive means that if someone does show up, they will feel included, and getting into the habit means outside here as well, you can propagate it. Okay, however, you didn't come here to hear me rant about diversity. You can do that anytime you like, but we're here to talk about C# and C# 8. So we have kind of an hour and a half, I'm guessing. We have a sort of hard leaving here at 8:30 so that we can get to Aberdeen Station and get down to Edinburgh tonight. Yesterday I spoke for about 2 hours on this. I'll see how we go. If you have any favourite features of C# 8 that you definitely want me to cover, let me know. I will absolutely definitely be covering nullable reference types in a fair amount of depth. There's always more, though, with nullables. And then we'll go on to the other more minor features, but we probably won't be able to cover them all in any depth whatsoever. So if there's something that you particularly want, just shout out. And likewise, if you have a question, please do shout. In particular, don't raise your hand because I probably won't see it because I will be looking at the laptop. Speaking of which, is that big enough for everyone? It's lovely to have such a big screen, so it means I don't need to make the font itself huge. Anything else before we get started? I think that kind of covers it. So C# 8 is now fully released. Hooray! Yesterday was my first time talking about it without having to say, oh, this could all change. Some bits of it only work with .NET Core 3 and .NET Standard 2.1. I won't be going into, for the most part, what works broadly, with .NET Framework. But there are some things like default interface methods that require runtime support. For the first time in a long time, I think possibly .NET 2 was the last time there was actual CLR support for something, and then there was dynamic typing, used some better bits in .NET 4, but didn't strictly require it. So the big feature is nullable reference types. And some people might tell you that this is about trying to avoid null reference exceptions, and it kind of has that as a side effect. But the real thing is you can make your code more expressive. This is a good thing. I don't know about you, I love statically typed languages, so the more I can express within the type system, that's a good thing. This is a little bit like going from C# 1, where we just had array list, and it could be an array list with anything in, to list of string. Well, this is a smaller change, in some ways, huge in others, but lets you give more precision about what your code is trying to express, whether that's as parameters, properties, whatever it is. So I'll start off showing you how it's normally enabled. I've currently got this hash nullable disable, which means this is not using nullable reference types at all. And in the project properties, I've got nullable enable. You may see some older projects with nullable context option as an MS Build property. That was kind of during previews and gradually got phased out. So now you'll just see nullable. My understanding, and I really should try it at some point, is that if you do file new project, in fact, let's actually do this, it's not so slow. Right, so if we do file new project with a .NET Core 3 app, in fact, is it going to actually ask me what version of .NET Core I want? No. But if I ask for a .NET Core app, then, do you know, it hasn't even put it. My understanding was that would put nullable enable in by default. But it seems that you're going to have to opt into it explicitly, even in a new project. Okay, that was worth checking so that I wasn't lying to you all. So it's dead easy to do. And when you do that, you will get a bunch of warnings. I'll say that several times tonight, but we'll see why, and it will all be fine. So this is C#7 code. We have a perfectly normal person type. This, if you're not familiar with it, this fat arrow here is saying this is an expression-bodied constructor. And this is, in fact, a tuple literal and then deconstruction. But effectively, this has become a really nice bit of syntax for just copy parameters into properties or fields. So anytime you've got really simple constructors, I recommend doing that. That's not part of C#8. That was available in C#7 already because of tuple literals and deconstruction. I have really started using this all over the place. It can get unwieldy if you need to do any validation of parameters as you go, but it's generally really nice. Other than that, so it's a person type with a constructor and 3 properties. That's all, and they're all read-only. In our main method, we're going to construct 2 objects. So one representing me, and I have a first, last, and middle name, and the other representing Miguel de Casa, who doesn't have a middle name. Now, I should mention that you almost certainly don't want to have first name, last name, middle name as a way of representing names. It's very culturally Western biased, may well not work in various things. You may find people with only a last name or only a first name, probably not only a middle name. That would be odd. But yeah, think about why you actually want people's names. If you just want to know how to write an email to them, then make it greeting name or something that says, this is what I'm going to put when I put dear, and then whatever they've asked for. However, it's really, really useful for demonstrating nullable reference types, which is why every demo I've ever seen of nullable reference types uses this. So we construct those 2 objects, and so far everything is fine. And then we call this print name lengths method twice. Print name lengths method, again, this is all C#7. I would expect people can understand this. We're just extracting local variables based on the properties, and then using old-fashioned format string just for simplicity. All of this would work as a single statement in an expression-bodied method using an interpolated string literal, but trust me, this will make it easier to demonstrate the feature, which is what we're all about. So it just prints the lengths of each of the first, last, and middle name, which will work fine for me. So it'll show first equals 3, last equals 5, middle equals 6, and then it will go bang with Miguel de Casa because as soon as it tries to dereference middle for middle.length, that will throw a null reference exception. I will just prove that and check whether the console app has the right font and things. Yes, that looks good. We have a null reference exception. Everyone happy so far? Because if anyone not getting that, I'll need to go back. Okay, so we would like to fix that. As much as anything else, because we want it to be clearer, we want everyone to know why there's a bug. Sure, we want to fix the bug, but we want to stop the bug from happening again, more importantly. So we're going to enable nullable reference types. I just deleted 1 line of code, but the entire meaning of the code has changed. This is why it's an opt-in feature. Normally, the C# team wants to keep compatibility. Everything means the same as it did before, with a few corner cases that I like sort of rootling into. But for the most part, nothing changes. It's all fine. As soon as you enable nullable reference types, the meaning of your code changes. Previously, the first name property, you could say, that is a property that will return a string reference or null. Now, it's a property that should, modulo some things I'll get into, always return a string reference. Shouldn't return null. Yay. That's a nice change if that's what you meant. If you kind of liked it being able to return null, we'll need to be able to express that. So we'll come to that. So it's obviously not just that first name property. Our parameters here are by default non-nullable, which means that we'll get a warning. So we're trying to pass in null, the null literal in this case, as an argument for a parameter that is non-nullable. So the compiler warns us saying cannot convert null literal to non-nullable reference type. The warnings could potentially use some clarification, but it's fine. So here we have two options, and it's important to understand that in almost all of these cases, there are different options, which is why the compiler or IntelliSense doesn't say, would you like me to fix all of your code and get rid of all the warnings I've just created? You need to actually make a decision. I'm quite fond of developers having to make decisions. It's annoying when they're boilerplate decisions, but in Node-time, for example, my date and time library, rather than the idea of, oh, don't make developers think, it's make developers think early and then make it easy to express that decision in your code. And fortunately, the same is true with nullable reference types. So the compiler's warning us, you're passing in null for something that shouldn't be null. We have an option. We could just say, OK, well, we'll use an empty string instead. And that would be fine. And now everything's non-null, no warnings, no exceptions. It's all good. However, that wouldn't really demonstrate the feature much. So we'll assume that the decision we want to make is that middle names are effectively optional, that they can be null. So we need to make this parameter here initially, as that's the thing that the compiler is complaining about. It's saying you're trying to pass in null for that. We need to make that nullable. Anyone want to guess how we do that? Question mark. This is good validation of the team's decisions, that every audience I've ever had has been able to guess what the syntax would be without me saying it. Right, so we've got rid of the warning from there. However, we now have a warning here, because we're now trying to copy the middle name parameter, which is nullable, into a property which is non-nullable. So, well, we kind of expected that because we said we wanted middle name itself to be nullable, the property, so let's make that nullable. Now we've gone from one warning to two. Do not be alarmed by this, and in particular, when you see this in your own code base, it doesn't mean that anything is wrong. If you find that you look at the same piece of code and keep adding a question mark, then removing it because it creates a problem, and you think, no, it really shouldn't be null, oh, but something else needs it to be null, but that needs it to be non-null, that shows you've got a bug, a design bug, effectively. You have conflicting constraints, and they haven't been added by C#8, they've been highlighted by C#8. This is a thoroughly good thing. When I did Node-time's conversion to use nullable reference types, I was pleased I only found a single problem like that, which is because timeZoneInfo.local in some bizarre builds of Mono can return null, which is kind of weird for that, but we would like to be able to handle that, and I had propagated that knowledge to bits of Node-time, but not other bits, and I found that because the compiler told me after I sort of went back and forth. But you should expect to basically play warning whack-a-mole. Okay, so let's look at the two warnings. One of them is pretty reasonable and expected. We have person.middlename, which is a nullable string, and we're trying to assign that to a local variable which is non-nullable. Okay, that's basically the exact same problem that we've seen already. The other one might be more confusing, and I won't go into it in much detail, just to highlight it now. The second warning for middle here is saying dereference of a possibly null reference. Now this is surprising because middle is declared as non-nullable. What's going on there? I'll come back to that when I show the opposite problem. So we can easily fix the first part by saying, well, we want that to be nullable as well. And we can use the null coalescing operator to make the type of this expression is now nullable int, and I should mention that nullable int and nullable value types in general are very, very different from nullable reference types because they are actual different types. When you turn on nullable reference types, it does not change the IL that the compiler generates other than to add some attributes in places. If you had a bug before, you will still have a bug. If you didn't have a bug before, then even if you've got thousands of warnings, you still don't have a bug. It's just that the compiler can't prove you've not got a bug. So nothing changes in terms of the IL, and that's a key takeaway. If you only take that away from tonight, please do. But the CLR has no idea. If you looked, there aren't two different types, nullable string and string. There's no nullable ref of t like there is nullable of t for value types. That has implications in terms of what you can't do for generics as well, but we'll come to that later if we've got time. So this is a perfectly normal C#6, I think, expression. We could have had this back in previous code, and it just makes it a nullable int, and if middle is null, then the value will be null. Otherwise, it will dereference middle to get the length, and that will be the value. All happy on that front? So when we run it now, we don't get an exception, but we get useless UI. Now, I am far from a designer. Anyone who's looked at my VDRUM Explorer will see that I really suck at UI design. It's one of the many things I suck at. So I think that looks ugly. I think we can do better than that. If we don't have a middle name, let's not even print middle. So let's write that. If middle is null, and I'll come to the else in a minute. If you're not familiar with using is null, this is a preferred way of checking whether the value of some expression, any expression, is a null reference. It would, of course, work with equals null, but those actually mean different things. This is calling string.op equals middle null. Obviously, I can't actually write that in valid C#, but it's calling an overloaded operator. We don't want an overloaded operator because we know the only time that that overloaded operator will return true is when we pass in a null actual reference. We just want to check, is this set of bits 0? So middle is null is more efficient and avoids calling an overload that you probably don't want to call anyway. The opposite of is null, if you want to do is not null, it would be kind of nice if you could write that, or maybe that. But in fact, what you need to write is something like is object or is string. And the compiler is set up that that's a quick, that's an efficient test. That will just be checking nullity. But those are sort of the modern ways of checking for null and checking for not null. So if middle is null, we don't want to print that, and we don't want to print that. Okay. However, we just make one last change. So I'll show that that works first. Yep, that's now a nicer UI. However, I made a change in this else block that is a little weird. So I'm now using middle.length unconditionally, but we've said that middle is nullable. We're not getting a warning here, whereas before, when middle was non-nullable, we were getting a warning. Okay, there's something screwy going on here, and it's that the compiler keeps track of more information than just the type. For each variable, and more, which I'll come to, it keeps track of, do I think this could possibly be null? So even if it's non-nullable, if we've assigned it a value from something that is nullable, it's saying, do you know what, whatever you've declared it to be, that can be null. So this code, with a warning, will still work without any exception, because remember what I was saying about no additional IL is generated. Even though we're assigning to a non-nullable value, non-nullable variable, it's not checking for nullity. This is really important when it comes to interoperating with other code, because suppose you have, well, in fact, this code is already kind of unsafe. or at least it would be if I made everything public. Because you can call this code from anything, and just because we've said that person is non-nullable, doesn't mean that it won't be null. I could call that from C#7 code. I could call it from C#8 code that doesn't have nullable reference types enabled, or I could call it from C#8 code that does have nullable reference types enabled, but has disabled, is ignoring the warning, or nullable reference type code that has the warnings turned on and even warnings as errors, but is using the dammit operator that I'll introduce shortly. There are various ways that this could be null. Likewise, there are various ways that any of first name, last name, and middle name could be null, which is why I've got the to-do here, and I'll come on to that later. So, the compiler has more information than than just the type. It knows whether things can be null or not. This is a little bit like definite assignment, where the compiler keeps track of, for each variable in any location in the code, am I allowed to read from that variable? I can only do that if the compiler can prove that every possible way that I've got to that bit of code, something has assigned to that local variable. But it's slightly scarier than that. Suppose I didn't want to have these local variables at all. If I wanted to use person.middle, person.firstname, nearly there. Okay, and we still don't have a warning. So the compiler has it doesn't just keep track of the variable, but actual property invocations as well. So it's saying if person.middlename isn't null, that's the only way we get into the else block, then it's fine to dereference person.middlename. If I were to just comment out this code and try to do it without the if, then we'll get a warning here. Yep, dereference of a possibly null reference. This may already have scared you. If it hasn't yet, I'll show you why it should. Hopefully, none of you have properties like this, but they're still entirely valid. So this is a property that says, hey, I can be null. And we've got code that uses it here that tries to say, well, if it's not null, I will print the length. Seems safe, except that just because it returns a non-null value on one invocation doesn't mean it'll return a non-null value on the next invocation, because we're actually using what's the second of the day. So it would be very, very, very rare for that to return null and then not null, or not null and then null, between that property invocation and that property invocation, but it is definitely possible. And the compiler is not issuing a warning about that at all. This is unsafe code, not in the /unsafe kind of way, but just this is code that could still go bang. No warnings. That's without using any C#7 code or anything that tries to ignore warnings. It's just not safe. You might think that that's a problem with C#8, the compiler's not doing its job, etc. No. The C# team is fiercely pragmatic. And if this code did give a warning, then your code would have huge numbers of warnings without ever having nasty code like this. Warnings that would be useless, and you would be swearing at the compiler every time you had to guard against it by having, oh, I'll keep a local variable and then assign that from the property, etc. No, it's much simpler to write this code and just trust that you're using sensible properties. And by the way, that you're not setting, if this were get set, then that looks fine until you've got two threads, one reading and one mutating the object at the same time. That's another way that you could get null and then not null, or not null, then null. But in both of those cases, you've already got horrible, horrible code. If you're dealing with things in threads in a completely unguarded kind of way, and they're mutable types, then yeah, you've got problems. C#8 isn't making anything worse. It's just not pointing out that particular problem. It will point out lots of other problems, but this is, if the compiler wanted to make things absolutely safe, it would be incredibly difficult. It's a bit like saying, okay, you know those stair gates that you have for toddlers? Like, so many buildings are completely unsafe for toddlers because they don't have stair gates. But do you really want stair gates on every single staircase in the world? Probably not. So, let's see, where have we got to? I think we nearly got to the end of the basic demo. Right. So, we've got a perfectly valid bit of code now, but we've still got this to do. Now, I've got some code that will help us with this, and I can call preconditions.check. I think I need to make it public first because I stupidly didn't commit that change from last night. Check not null, and shouldn't. Oh, it's precondition. Sorry. I always call it preconditions in my real code, and I've written this many times, and there'd normally be a second argument, which is the name of the parameter, but and you can see now how using this tuple becomes a little bit uglier than it was before. Okay, we definitely want that code, and now we've validated things, and we want that code for the reason that I was giving earlier on of people could still pass null in. This isn't the same kind of type safety. They wouldn't be able to pass something that isn't a string. They can't pass a stream in or something like that. The CLR protects us against that. It doesn't have any protection against null values for things that shouldn't be null. So we still need to validate that. And at the moment, we need to validate that by hand. How are we now going to test this? Because I like my code to be tested. I want to have a test that tells the difference between this is good code and this is not good code. So we need to write a test that would be roughly, this won't compile, but, and I'm only writing it in here for the sake of simplicity, and we write something like assert.throws argument null exception, new person, null, quote, 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 quote. Okay. However, that will, if we had an assert thing, if we just try to write that same code here, that will give a warning. Now, I don't want warnings in my test code either. You know, I clearly don't want it in my production code, but as soon as you start saying, oh, warnings are okay most of the time, then you don't spot the new warning that is actually an awooga, there's something badly wrong here, you really need to fix this. There are a few ways around this, but the language integrated one is the dammit operator that I believe is something like the null assertion operator or null safe operator, I'm not entirely sure. And the reason I'm not sure is I can't be bothered to learn it because we're going to call it the dammit operator. If I start talking about the Microsoft compiler framework or something, you might be wondering what I'm talking about. But if I talk about Roslyn, everyone knows what I mean, right? This is the same kind of thing. This was what the team calls it internally, the dammit operator. Now the team is, you know, if you hear Mads Torgerson giving this same talk, he would probably refer to it by the official name, but as a community member, I'm going to keep calling it dammit, and I hope you do as well. And it basically shuts the compiler up. It says, whatever you might think about this expression, please treat it as if it's not null. So earlier on, we could have done the same thing if we had string middle, it's person.middlename. There's a warning. Shut up compiler, and it shuts up. Okay? It's a little bit like a cast. So suppose we had object x equals new object. We can't write string y equals x. That's an actual error, but we can tell the compiler to shut up. I know what I'm doing. It's a cast. Just fine. There's a big difference, which is that this is validated at execution time by the CLR. It checks that the cast really, really is correct. That null, the damn it operator, sort of ignore it. No, that's completely ignored, which is actually what we want here, because we want to get as far as this, because we want to be able to pretend that we aren't null aware. And the other way we could have done this would be to do hash nullable disable, and then hash nullable enable. There are other values for nullable, by the way, which I need to look into in more detail, but they're basically around what do you do. Suppose you're using NodeTime v2, which doesn't have any nullable support, and you're using the result of dateTimeZoneProviders.tzdb. Okay, that's a property that I've told you will never return null. Do you know it'll never return null? What does the compiler know about it? It doesn't have any attributions. What should the compiler assume? And there are basically different versions of the nullable options for please be paranoid and assume that everything can be null and I really should be checking everything if I haven't been told otherwise, versus I'll kind of trust that if you're assigning to a non-null variable and you're calling this unknown thing, then I'll assume you know what you're doing. You could, yes, you could indeed just not turn on, not even disable it, but just not enable it at the test project level. However, that would probably, I don't know, it just makes me feel a bit dirty not being in, there may be various other things. I kind of like to know when I am deliberately violating something, because the only times when I should be getting this warning are when I'm doing an assertion about that. And there have been things where I found, hey, I'm passing null into this and I really shouldn't have been, and that's kind of a problem, and why didn't it even break before? Oh, because something else was happening first, or whatever it is. But yeah, I would personally recommend using the single character, just, I know what I'm doing, and the exclamation mark is nicely shouty for that. That's one reason to use the dammit operator. The other is when you've got cases where you know that it won't be null. You don't want to add an explicit test for it, as in a check for it, because maybe if magically you're in a situation where it was null, then actually a null reference exception is probably the best thing that could happen anyway. And so I really don't want to be bothered by this. Maybe I've got an invariant, certainly in NodeTime there's one example, I've got an invariant, I know that either this is null or that's null, but never both. So if I've already checked whether that's null, and it is, I know that this isn't null, just let me return it. And I don't want to double check again at execution time for something that's always going to be right and leaking little bits of performance for no reason. So again, use the dammit operator there, but sparingly. I found a few places, most recently with string.isNull or empty, which I'm coming on to as the very next topic, where there are bits which are either Roslyn bugs or I haven't done something else, and there are ways that I can get around it, but right now I'm just going to put the dammit operator. I found it's a good idea to have a particular way of notating that in a comment, something like to do nullable, or maybe it's to do dammit. Anything that you can find later on, and find those places where you've got an exclamation mark and you don't really want it. Here, we do actually want it. In other cases, we would like to get rid of it, because we want the compiler to be, we want to trust the compiler. And if there's a way that we can explain something better to a compiler, great. So it's worth having those and explain why you've got the dammit operator at all. Okay, I mentioned string.isNull or empty. Just time check, okay, we're fine. So string.isNull or empty is an interesting method because it's not conditional return, it's, I had this problem yesterday. I can't find the example. Oh, it is conditional return. Okay, so imagine that instead of my own method, this was just string.isNull or empty. We're talking exactly the same signature here. This is just I've got my own method to show how it's decorated. What should the type of the parameter to string.isNull or empty be? Well, it should be nullable string, because it's fine to pass null to string.isNull or empty. It would be really obnoxious if string.isNull or empty threw an argument null exception if you passed it null. That would be just mean. But once you've called string.isNull or empty, if it returns false, you know that that string was not null. And it would be nice if the compiler was happy to take that information as well. So here we've got this exact thing. So if it's null or empty, we can say it's null or empty. We don't know. It still may not be null because it may be empty. But it's definitely may be null. Whereas in this else block, we know as humans that it won't be null, but there's no way of expressing that in just the type system. So we need to have some extra tools. Originally, this was going to be done as an attribute with some text in, and there'd be a sort of mini language to explain the sort of correlation between inputs and their nullability and outputs, and either their nullability or their return value. Excuse me. But I think the language team decided that there were really only sort of 4 or 5 key scenarios that needed to be captured here. So rather than have one attribute and have to define a whole new language, which is kind of a big deal, especially if you want multiple people to implement that. We all use Roslyn now, but it shouldn't be such a barrier to implement a new C# compiler that you've got to do a whole extra language as well. So they thought, well, we can do this just with a bunch of different attributes. So in this case, string is null or empty has the not null when false attribute applied to this parameter. So if what this says is if the return value from this method is false, then text was not null. And the compiler can then do reasoning based on that. Here's another sort of the opposite thing for dictionaries. So dictionary T key T value. Imagine we have a dictionary bool string. Let's get an import. Bool string. Okay, so if we do if dict.try get value, so if false out string text, okay, you might expect this to compile without a warning, because dictionary of T key T value has bool try get value T key out T value value. So in a dict bool string, T value is non-nullable string. However, dictionary also says, well, if the key isn't found in the dictionary, then T value should be the default value for the type T value. And it's unfortunate that the default value for a non-nullable reference type is null. You feel that you should always be able to write T value equals default of T, but if T is a non-nullable reference type, this will give you a warning. And it's kind of, but it's kind of unavoidable as well, without completely changing the type system and introducing option types, etc. The idea of this whole thing, and any F# fans can say, we've got it better in F#. Yeah, because it was introduced later. It wasn't trying to retrofit avoiding nullity and expressing things onto a language that has been in use for nearly 20 years and has millions and millions of lines of code that aren't going to all be changed for the sake of this. The idea was to let you gradually introduce this and you get value without having to take a complete rewrite of everything. So, try get value, even though this is declared as non-nullable, if try get value returns false, this is going to be null. And that's what this may be null when. So if it returns false, then the out parameter might be null despite the type system. And if we say, well, only do it, why is this? Have I got text somewhere else here? Nope, not string text. That's intriguing. Sorry? No, because it should. I would expect it to be okay, precisely because I'm saying if there is a value, then it really should be non-null. I would have to look at that more carefully. It's possible that yeah, I will have to look in more detail. That's not something I've run into in real code, so I'm not sure why. But the idea is that maybe null when understands, and it did, using not or not made a difference when I was using text as to whether it could be null or not. I guess there are cases where you don't want to be able to assign, it's sort of useful that it requires you to assign a nullable variable, even if you're not going to use it later. It's saying, well, it really, really might be null. Okay, it'll only be null. The compiler will know that it's not null when try get value returns true, but the variable is still of type nullable string. And that particularly makes sense. Imagine that you have an out parameter that is itself a string that you receive into your method. You don't want to be able to pass that down to try get value, because who knows how that's going to be used. So you can't start assigning null to variables that you don't know how they're going to be used. So it kind of makes sense, but there are lots of these little quirks in reality. Right, that's an example of exactly what I was saying. There's two more attributes I want to show. One is familiar, hopefully, from Link to XML, which has a bunch of operators, conversion operators and things. If you have X element equals whatever, then you can cast that X element to a string. If it's not null, it will take the text within the element. If it is null, it returns you a null reference. So that's sort of null propagation. I've got a slightly simpler example here without any conversions of a method that takes either a string or null. If you give it null, it returns you null. Otherwise, it returns you the same input just twice. So if you pass in hello, it will return hello, hello. Which means that if you've got something that's not null to start with, and you pass that in, the compiler should be as happy that the return value is not null as it was that the input was not null. Make sense? And the way that we do that one is this: not null if not null. I'm not going to exhaustively go through these attributes. They are reasonably well documented, with the exception of the last one. But the main thing is to get across the idea that there are things the type system can't express, and you can, at least in some cases, in many cases, still express it. So if you find yourself having to write the dammit operator because you want to tell the compiler something more, and you're calling your own method, then you may be able to use one of these attributes to avoid the dammit operator. That's a good thing. Okay, final attribute is one that I think by now it's well documented. It wasn't before. So this currently has the XML documentation of specifies that an output is not null, even if the corresponding type allows it. Now, I don't know about you, but this is an input parameter called input. It doesn't look like it's an output to me. But when you apply the attribute to it, That's saying, dear compiler, if this method returns without throwing an exception, so if it returns normally, then that means input was not null. Which is why we can call check not null on text. Text is a nullable thing. It should be fine to call check not null on a nullable input, otherwise we've got bigger problems. But it will throw argument null exception. And in fact, yeah, you could argue about whether that should be just T, in that you should only call check not null for things that really shouldn't be null. But importantly, after you've called check not null, it doesn't warn about text.length. Even though we've got a non-nullable return type, but even if we don't use that at all, it still knows that check not null not throwing means that text is not null. So if we don't check, then we get a warning. We do check, and this, and in fact, even if we do check, but we don't have that, we will still get the warning. I do wish Roslyn were a little quicker, because my heart comes into my chest every time that I have to wait a few seconds, like, there is going to be a warning, isn't there, compiler? Isn't there? But yeah, so it works. That's an important one to know about, partly because it's really not obvious from the initial documentation. One final bit, which I think will wrap up nullable reference types. There are all kinds of things around generics that are difficult. Almost everything to do with generics and nullable reference types is awkward. But in terms of the validation that I showed before, it's not part of C# 8.0, but I'm hoping that in C# 1, I would be able to write this. The position of the bang after the variable name rather than after the type is deliberate. I'm not sure that I like it, but it is deliberate. The team are saying, well, no, it means something very different from if we allowed this. That still feels nicer to me, saying, you know, I really want this to be a string. Please make sure it's a string. But the team prefers having it on the parameter name itself. If this comes into Roslyn, this will mean, please on constructor entry point, in this case, just validate the parameters for me. It's just a shortcut for writing that preconditions.checkNotNull, and will be much more pleasant. As I say, I'm hoping it will be in 8.1 rather than having to wait for 9, etc. It feels like the kind of thing they should be able to add fairly easily. Right. One very, very final thing. I mentioned string.isNull_empty earlier on. If you are writing a .NET Core 3 or Net Standard 2.1 bit of code and use string.isNull_empty, it will behave like my method does, knowing that if it returns false, then the input wasn't null. If you're targeting Net Standard 2 or Net 4.7.2 or etc., you will not get that behavior because those frameworks don't have any of the attributes applied to the methods. And you know, at one point there was a big plan of, yep, we will retrofit everything and all the frameworks will have sort of sidecar assemblies that the compiler can use to know what can be null or not null in existing code. That didn't happen. And I think less of the framework, even in Net Core 3 and Net Standard 2.1, is attributed than I would like. But things like string.isNull_empty definitely is in Net Core 3. You will need to either use the dammit operator, or you could write your own string is null or empty in exactly the same way that I have that delegates it, and you know, the JIT compiler will make it fast and you can apply the attributes. Those attributes won't be available to you because they're part of Net Standard 2.1, but it's fine to have the attributes within your own code. They need to be in system.runtime.compiler services. You should absolutely make them internal so that you don't get other code depending on you exposing those attributes. and then remove it when you start targeting other frameworks, more modern frameworks. But the compiler doesn't care which assembly they come from. It only cares about the namespace. OK. Any questions about nullability before I start rushing through the other features? You're very quiet. I spotted this yesterday in Sheffield as well. Right, that's, OK, good question was, it feels like it should be called non-nullability. And I sort of see what you mean, because we've always had nullable reference types because string was nullable before. It's called nullable reference types because when you use the new syntax, you make something nullable. So turning it on makes your existing code non-nullable, and you use the new syntax to make things nullable again. And it doesn't come up other than in titles of talks and in documentation, etc. Whereas the choice to make non-nullability the default, that's a big decision that's important. Because they could have done it so that everything was nullable by default, and you put an exclamation mark for things that you didn't want to be nullable. And then, when you compile your code, after turning the feature on, everything would compile with no warnings. And it wouldn't have actually told you anything at all. The expectation is that most code should be using non-nullable reference types. Most code doesn't really expect stuff to be null. So if you start by making that assumption and give warnings for where things might be null, then you will rapidly end up adding the right annotations. It's sort of be strict. It's a bit like C# has everything as the most private it can be declared by default. If you forget to put an access modifier on, and you're trying to use it from somewhere that you don't have access, so if you have a method that you want to call from a different class, oh, I forgot to put the access modifier on. Yeah, the compiler is going to tell you about that because it's implicitly private. So you then need to make it internal or public. If it went the other way round, which Java has this weird package access by default, if you forget to do something, the effect is that you don't get an error when you should, and that there are things that you ought to make private that you haven't done. So making things more restrictive, which in this case means definitely not null, lets you uncover your problems earlier, which is a good thing. Sorry? I have turned this on in NodaTime in 3.0, which there is now a beta of. Aha. Right. Okay, good question. So the question for the recording is sort of how long it took me to turn it on in NodaTime. I sort of cheated in NodaTime by doing it beforehand, in that I think everywhere, the intention was that everywhere I had a reference type in the public API at least, I had an attribute that was copied from JetBrains saying not null or maybe null, which meant that I'd already done the thinking, and the rest was just, I can't remember whether I actually used find and replace with a regular expression or did it by hand, but the thinking had been done beforehand. You may well not be in that situation, and NodaTime is, it's only me writing it, it's a relatively small code base. Still, I think it took 5 or 6 hours for the initial pass, and then I've since found a few more things over time, as tends to be the way. In terms of real code, or NodaTime's production code, but production commercial systems, which tend to be much bigger, I'd recommend turn it on Leaf projects first, because if you're trying to work with a dependency that doesn't have it turned on, you're just on a hiding to nothing. You will be guessing whether something should or shouldn't be null. Expect everything to be thousands of warnings to start with. You will rapidly be able to fix thousands of warnings, which will leave you with thousands of warnings in different places. It's slightly disheartening, but do it. Particularly, actually, not for the commercial code. I do care about commercial code, of course. I care much more about open source code because this will work much better by the time all the open source code in the world has adopted it. And when you're depending on stuff that is going to tell you, hey, this won't be null or this might be null, rather than I'm not going to tell you, so it might or might not be, and you've got to decide whether you're feeling brave or not. The more open source projects that can do that, the better. So in particular, if you're thinking, oh, I want to do this in my commercial stuff for work, but I've also got this open source project, do it in the open source project first, because A, it will be easier, B, you'll learn loads, C, you can then blog about it and give actual examples and say, look at this commit over here that had some trickery in it. And you'll learn what works and what doesn't, which will make the commercial stuff easier. The good thing about that is you will probably end up with a period where your commercial code no longer builds, because no doubt you've all got warnings as errors turned on. And you may even want to commit to the code base while it still doesn't build. And that's kind of nerve-wracking as well, probably in a branch somewhere, but you don't want... The size of the commit would end up being completely unwieldy if you wanted to do it for the whole code base at a time. You can do it on a per file basis. I would probably try to do it on a per project basis, because otherwise you've got the same problem of, well, I've got this code that I'm trying to instrument, trying to nullify, whatever, but it's calling into all this other code that I haven't done yet. And within a project, you may well have references, cyclic references, that you can't easily find a leaf class that I will do just this one class. There may be some of those. It's painful, do it anyway, basically. I would say that actually coming up to Christmas is a good time to do it, because I don't know about your production pushes. At Google, we certainly have a production freeze a bit before Christmas because no one wants to be paged on Christmas Day. Well, that's fine. If your code doesn't build, you're probably not going to be paged because it's failing in production, because it won't be in production. I hope you don't push to production code that doesn't even build. Stranger things have happened. Yeah, try to plan ahead, talk to your business and say, do you know what? This is going to hurt. This is going to take all our engineers for a week or 2 weeks or whatever. You'll get nothing from it other than higher quality code that means we will be able to move slightly quicker, and I can't actually quantify how much quicker in the future. That's quite a hard sell, but communication is a big part of being a software engineer, so it's a good time to learn your negotiating skills. And okay, I said that flippantly, but it's entirely true. It is a hard sell, particularly if your managers, etc., aren't technical. But anyone who understands technical debt, you need to tell them, we've suddenly inherited this debt because we've always had it really, but we couldn't see it before. We can now see it. Please let us fix it. Okay, right. Need to definitely go in 50 minutes. Let's look at patterns first and switch expressions. Any other questions on nullable reference types? Nope, okay. So, switch statements have been around forever. I will, as we're short of time, I will skip down to, these are multiple implementations of the Fibonacci sequence. Here's one using a switch statement. And that's kind of nasty because too much is happening in the default clause. I prefer this version above, but they're basically the same. We have a switch statement. It has this syntax of switch brackets value as if you're calling a method or something, and you can't do it without the brackets. And then you've got case colon, and default, and these are all sort of slightly magical. Switch expressions are exactly as they sound. They're like switch statements, but they're expressions, and they have quite different syntax. So here we have a version that's using it still in a regular method, and I'm just emphasizing that this really is an expression because I'm assigning a value to a variable based on it. So the differences in syntax, and just out of interest, is there a convert switch to conditional? No. Convert switch statement to expression. Yes. Okay. So I've been sort of waiting to see that, and it's possible that it's been there for a while now. So you may not need to know how to do this by hand, but you'll need to know if you want to be able to write them yourself from the start. Instead of switch n, we have n switch. So effectively, this is a binary operator where the left-hand operand is an expression that produces a value. The right operand is a comma-separated list of, I will call them arms because Mads does, but each switch arm consists of a pattern, a fat arrow, and another expression that is used to produce the value. So this is fat arrow syntax. It has nothing to do with lambda expressions, nothing to do with expression trees, delegates, anything like that. It's just the syntax of equals greater than. I wish we had a less kind of body-shaming implication name for it than fat arrow, but that's what people tend to call it. Do not call it lambda. Not a lambda expression. So this operates exactly as you expect it to. So it works exactly the same way as the switch statement. As of C#7, I want to say, when we got patterns, you should always think of it as going through checking each case arm at a time. So it first checks, is n 0? If so, I will evaluate this expression. If it's not, I'll move on to the next expression, etc. So we don't have case anymore. That's gone. We don't have the colon. We have a fat arrow. We don't have the return because in this case, we're returning directly from the method. If we wanted to do the same, let's make this a fib3b. We could declare result first, and then do result equals 0 break, result equals 1 break, and result equals that. Now it's horrible because we don't have a statement anymore. We need to do if n greater than that. I suppose, yeah, we can do it just as result equals that break, and then return result. And let's actually iterate recurse rather than calling a different implementation. Right, so this is pretty horrible. You know, we have to have a break after each statement because a switch statement can have any number of statements in each case. A switch expression has to have exactly one expression. Now that can be a lambda expression that itself contains multiple statements. Don't do that, please. I wrote the demo code for that last night and it was not pleasant. So it's just an expression, and that expression is evaluated, and that becomes the result of the expression, which means we don't need to assign 3 different times to a variable that's declared without an initial value and nastiness. We can just say int result equals evaluate this switch expression, which means we can actually do the whole thing in an expression-bodied method. Again, not a lambda expression. And this is how I would normally write this. Okay, I'm not trying to be particularly terse and demonstrate things. If you've got a method that can be expressed as a switch expression, then think of that as a good thing. While you can do stuff with side effects in it, it's at least a reasonable expectation that this is a simple method that takes an input and maps it based on multiple conditions to an output. Think something like calculate discount based on this pizza order, and you can match various discount deals and things. It's really nice. Most of the places in NodeTime where I've used switch expressions, I've managed to convert a method that previously was just the switch statement with return statements for every case into an expression body method. I believe I still have, let's just check, if I look at the node_time GitHub repository, I believe in the branches, view more of your branches. Oh, no. No, this is in the main node_time. In the Jon Skeet node_time branches that never got merged into node_time, I have switch patterns. So that's switch expressions and some pattern stuff. There's also a bunch of branches that I should probably get rid of at some point. But I will try to keep that branch alive because that shows what I did through the whole of node_time. It's only got 3 commits in it, but they're all just moving from a switch statement to switch expressions. And yep, there we go, expression body member. This one needs to do some things first, expression body member, etc. Okay, so that's reasonably, it's just syntactic sugar, but it is nice. It feels really nice. I really hate it when I have to write code. Well, until last week, I had to write code that naturally would go to a switch expression, but I wasn't using C#8. The other part of the sort of pattern-related features is enhanced patterns. So there are 2 new kinds of patterns in C#8. There's the property matching pattern and deconstruction pattern. And I have one example that demonstrates both. So the setup for this is we have an item class with subclasses of weapon and artwork because, you know, what else would it be apart from a weapon or a piece of art? And I want to write an interesting fact about each of my items, and something can just be an item without being weapon or art. So a weapon has a damage level, and an artwork has when it was created. So we have something that isn't either of them, a rocket launcher, work by Joan Miró, croquet mallet, a bad joke has no damage, although my children may disagree, and Sunday in the Park, Sunday afternoon on the island of Le Grand Jatte by Sura, which I was definitely not going to write out in full. So we have this get fact method that takes just an item, uses a switch expression, although the same things would work if you used the is operator with these as patterns. So if I do that and get rid of the guard bit, that is valid C#7 with a type pattern to say, is the type of the item at execution time a weapon? If so, you assign the pattern variable W, the weapon reference, and then you can use w.damage, for example. Okay, that was in C#7. The new bit is the braces. So this is saying, in the first one, this is also known as recursive patterns. So we're going to look, okay, it's got to be a weapon to start with, but it's only a weapon, or we only want to match if it's a weapon and the damage property matches this pattern, which happens to be the constant pattern in this case. But if it is exactly 0, then return it that it's harmless. This is another pattern, the var pattern, and with a pattern variable of d. So if it's a weapon with a damage that we are capturing into the pattern variable d, and then we have a guard clause that says when d is greater than 500, then we'll return that it's a heavy weapon. Otherwise, we'll capture the damage, but not even capture the weapon itself, but record that it does a certain amount of damage. And then finally, if it's an artwork, we will match anything because the var pattern matches any time. The only reason why we can get away with having both of these clauses is because we've got a guard clause here. Otherwise, this would always match. So this is going to match the date time, but it's going to deconstruct it into a year, and we don't care about the month or day. So this is another new type of pattern. So the braces are one type of pattern, and this is another that deconstructs into year, discard, discard. And the reason it can do that deconstruct is because we have a deconstruct extension method on datetime. It could have been just an instance method on datetime if I could change the datetime type. Deconstruct would not be the first thing I would do if I could change datetime. That's a whole different talk. The deconstruction itself started in C#7, but you couldn't use it in pattern matching, whereas now we can. So it matches, and we get to capture the year. If you don't need to do the type checking first, you can match. So if we're getting a fact about just any weapon, then you can just put the braces. That's still a pattern, and you're just doing the recursive property bit. And obviously, if there are, let's have public string name, and in fact, no, we've got the description already as a string in the base class. So we could do description Fred, and that will only match if the damage is 0 and the description is Fred. I don't honestly know how useful this is going to be in most code. It's the kind of feature that you may use once or twice in a project, and in those couple of places, it will be fantastic, and it will be really easy to use. But if you try to shoehorn it in everywhere, your colleagues will absolutely hate you. So use with care, and it will be delightful. Don't be that person. You know who I mean. Okay, next. Indexes and ranges. Okay, mostly because I like annoying people. You'll get cross, and then I will explain, and you'll get less cross, I promise. So there is a new type in the framework called index, and another new type called range that I will introduce in a minute. And there are two ways of creating an index. One is with just an int, and the other is using the new caret operator. So we've always had caret as XOR or bitwise XOR. This is now a unary operator, only has one operand, which is the thing that comes after it. And it's saying this is 1 from the end, whereas this is 1 from the start. So an index always consists of a non-negative value and an indicator of, is this from the start or from the end? And it defaults to from the start, and you use caret for from the end. I think you can probably use new index, 1 from end. So this is effectively what's going to be generated by that. And it's a struct. And you can use this in indexes. You can, I believe, and I haven't tried this, you can use it if something has provided an indexer. So if we hover here, you can't really hover over an indexer. But I believe that the string class actually provides in .NET Core 3 an indexer that looks like this. So public char this index, whatever. Text.charat, whatever it would be. But I also believe that there was a fairly recent change that means you don't have to have an indexer accepting an index. If your class exposes either a length or a count property and an indexer accepting an int, then it will just do the right thing. So you can pass in an index, and the compiler will emit code that says, well, if it was an index from the end, then I will do length minus that. Otherwise, I'll do just the value to get at the index. Which leads me to the bit that might make some of you cross. So if I write text index, where index is 1, what's that going to return when text is conference? Oh, correct. So that's what happens if we do 1 from the start. What's this one of 1 from the end going to return? Okay, some C's. Hands up for C. Hands up for E? Okay, roughly equal with about half of you not willing to commit. That's fine. I would just point out that if you had committed but got it wrong, I would not have done anything nasty to you. Try committing next time. It is, in fact, E. And a lot of people say, no, that's what you should get from caret 0. 0 from the end to match from the start. And I say no. Mostly because when you look at range, it will definitely be obvious. But also, in fact, I had already told you the answer, kind of quickly, but I'd said that if you're using this, that's equivalent to sort of a synthetic method of, so suppose we have public char this int. Okay, we're just always going to return x because this is the boring bit. This is the interesting bit. Index dot from is from end. Boom. So if it isn't from the end, we're going to return this index dot value. Otherwise, we'll return, and we'll have a just randomly this index length minus index dot value. Okay, so for one thing, this is kind of what I described very quickly, and at that point, you should know that if you do text of text.length minus 0, that's going to go bang, because that's getting it from beyond the end. We all know that we need to put the -1 there if we're using the normal indexer. So the fact that it's just length minus index.value suggests the behavior. Now, it could have been written so that the compiler would add a -1 there, but that's already feeling, we've got an off by 1 bit of code for no obvious reason. Yeah, it makes caret 0 do something that some people like, but anytime there's a -1 or a +1, there ought to be a good reason for it. The way I would justify it is that the index doesn't represent a character, it represents a cursor. So there is the cursor, if you can see it flashing just before the C, that's the cursor at index 0. That's the cursor at index caret 0. And what's the character? When you use the indexer, it takes the character after the cursor, which is off the end of the string. Whereas caret 1 is before the final character. So that's argument 1. Or argument 2, I guess, with the it looks nicer in the implementation. Now let's come on to ranges, where it becomes much more obvious, I would say. So a range is a pair of indexes, a pair of any two indexes. So this is a range from, and dot dot is the syntax here. This is a range from 1 from the start to 2 from the end. It would be fine to be 1 from the end to 2 from the start. Or 1 from the end to 2 from the end. Or 1 from the start to 2 from the start. All of those are valid, as is that, or that, or that, or that. So if you don't put anything at the start, if you don't have a left operand, it's equivalent to putting 0. If you don't have a right operand, it's equivalent to putting hat 0. You can then use an indexer with a range, and in the case of string, that's equivalent to calling substring. And at this point, that feels nice and appropriate, that this, which is equivalent to all of that, if you take a substring that is 0 from the start to 0 from the end, and substring's always been end exclusive, you get the original string back. If caret 0 meant, the last character from the end, you'd end up with a weird situation where either it would be inconsistent with the use in range, or range would return something bizarre, and to get the whole string, you'd need to do, you couldn't do anything because you can't have a negative value in the index. So that's argument 3, I think. Argument 4 is that you get a really nice property, which is range 3 is 3 ... 7. So range 1 and 2 exactly cover the same as range 3. So if I were to do text.range1 plus text.range2, so that's just normal string concatenation, that's equivalent to text range 3. So when the excluded bit is equal to the included bit of another range, you get abutting ranges that cover things nicely. That ends up being a nice property to have. So there was a lot of discussion about this. There are some alternatives where you could say, oh, I want this to be a range with an inclusive endpoint. But that makes things more complicated. So even if you're initially surprised, just live with it, and it will rapidly become the obviously right thing because it's what you've used. You don't get a choice about, if there had been 2 versions going on in parallel for a couple of years so people could get used to the other behavior, then it might be a bit worse. But to be honest, in a year's time, if you've been using this, you're going to say, why did Jon even spend 5 minutes on this? Now, importantly, this doesn't look like an expensive operation, but it is, this one, because that's calling substring, effectively, which creates a copy. Not good. You can do all of this with spans as well, and if you haven't used spans yet, I'm not going to go into the detail today because that's a whole other talk, but they're a cool way of representing part of a string or array or other block of memory in a uniform way, and there's span and read-only span, and you can say, I wish to get my text in the form of a span. Note that this is as span rather than to span, and just like in LINQ, you have toList and toDictionary that create new objects that contain copies of the data, whereas you have as enumerable that is a view over the existing data. So we have as span is a span-like view over the string. Now, when I slice it, this creates another span. This isn't copying any data at all. I've created another very small block that basically says, oh, I'm this bit to this bit of this string. Really, really cheap. So if you're parsing some enormous file, you can create spans all over the place and you're never copying any data. And I believe that, well, I know that in .NET Core 3 there is a new JSON API that I suspect is all span-based and much, much more memory efficient than, say, JSON.NET, because it can just do a load of work without ever having to copy substrings. So be nervous anytime you use a range to index into a string directly, because you will get a copy. You can do this with arrays as well. So if I had new int 10, value slice is, in fact, I'll call it value copy. I believe I can do values range 1. Is it going to compile? It is. But that will again copy things. Whereas if I had span of int values span is values.asSpan, then I can take values slice is values span dot slice. And then if I change 0 is 10, console.writeLine, let's take our initial, sorry, I didn't mean that. I meant to actually use the new feature. That would print 10 because the span is just a view over, and the slice of the span is a smaller view over the array. No copying involved. We're modifying. It's all sort of transparent. All cool stuff. Spans are going to be great. It's still early days for actual usage of them, but over time, you'll increasingly use them. Right. I will briefly, probably not even show you details. There are new async features, particularly for disposal. So there's an iAsync disposable, I think, or iDisposable async. for stuff that needs to be cleaned up asynchronously. More usefully, I would say, is async iterators. Unfortunately, it's kind of breaking from, we've had async enumerator in system.interactive.async for a long time. It is not compatible with that. And if you're using async enumerable, then when you update to Netcore App 3, you will probably want to update to a newer version of system.interactive.async that doesn't include it. You may need to rewrite a bunch of code. If you're publishing libraries, this will mean a new major version. It's all breaking. gRPC has exactly this problem at the moment. It has updated from 1.22 to 2.23, and so if you try to use the latest version of gRPC with the client libraries that I build, it will go bang. And you'll report it on GitHub, and I'll say, please downgrade gRPC. And that's kind of annoying, and we need to upgrade our version of gRPC. But the result is that you can do a wait for each. And that's really nice. And you can also do yield return from a method returning an async enumerable. So while the breakingness is bad, let's get it out of the way nice and early. There are subtleties in all of this asynchronous stuff. Primarily, how do you do the equivalent of configure await false, and how do you pass cancellation tokens in? I'm not going to go into either of those right now. Other fairly big feature that I'm not going to go into in detail is default interface methods. Previously, in previous episodes of C#, you couldn't do this. So this is an interface, and it's got an implementation. Whoa, crazy stuff. You also couldn't do static fields inside an interface, or another type within an interface. All of these things are now available. There's hot debate about whether this is a good thing or not. It is frankly copied from Java, and part of the reason is so that Xamarin can accurately represent Android APIs, and that's kind of reasonable. I think it's really nice being able to give a default implementation of an interface. So, for example, iEquality comparer of T, there is an equality comparer class, and you can do equality comparer of T.default. It would be nice if you could do iEquality comparer of T.default and not need to know that there's this kind of default implementation. And you can even put the default implementation inside the interface and hide it away in there. There are other things you can make methods within the interface internal, even if it's a public interface, which means if someone tries to implement that outside, they will be told, hey, you're not implementing internal only. And by the way, you can't. In fact, I don't think the error message will say the and you can't, but it does stop it from being implemented from the outside. And there are things that you have to do around explicit interface implementation that also is the case for default methods. There are nice things about default methods compared with, they're often used in the same breath as extension methods. Oh, we have extension methods, we don't need default interface methods. There's one really nice thing, which is, say the count method in LINQ. Okay, that has, in link to objects, there is specific optimization for iCollection of T and iList of T and possibly a couple of other things. What if I've got my own collection class that has a count property, and I can tell you the count really quickly, but I don't want to implement iCollection of T or iList of T for whatever reason. It's just not appropriate. Link to objects has no way of knowing it can make that optimization. If instead, LINQ had been built as, hey, there's a count default interface method that the default implementation loops over everything, then list of T or anything else could have overridden that count method to provide the efficient implementation, and it's sort of more opt-in. It makes interfaces a lot more like abstract base classes, but they can't declare state. And the reason they can't declare state is you can still implement multiple interfaces, and it would be weird if you didn't know how many fields you had based on what interfaces you're implementing, and there are still diamond dependency problems, but the way that they're called via, you can't call m twice via an implementation directly. You have to call it via the interface, which means you can't end up with ifoo and ibar both having call m twice and not knowing which of the default implementations to call. If a class wants to provide its own method that effectively overrides both of them, it can do so, I believe. I'd have to check. It may be that it's awkward to do them both. You'd have to do them separately, calling some internal method. But this is all to get around diamond dependencies and multiple inheritance, normal kind of problems.
So if you had an interface that had void call m twice but no default implementation,
yep,
it wouldn't by default pick up the one that's on ifoo.
As in, so if I had interface ibar and this, okay, and we're saying if we had class baz implements ifoo ibar, this is the kind of question I love getting because I don't know the result automatically. So I can do public void m, fine, and we're still not implementing ibar. It does need, what we can probably do is public void call m twice, and then ifoo this dot call m twice, I think. Yeah, so that's how you would sort of delegate to it, but it's not going to implicitly pick it up. Was that what you were asking about? Okay, good. There are so many details here about exactly what you want to do that it can be tricky to talk about without talking past each other. Okay, anything else on default interface methods, or shall I move on? We're rapidly running out of time. So those are sort of bigger features. There are a bunch of little features. Little feature that you'll find useful, using statements without any braces. This is equivalent to that, which is then equivalent to, sorry, I do need to put more brackets in at this point. So if you have a using statement without any braces and without even the brackets, then it just extends to the end of the block, because that's often what you want to do, and you don't end up with the extra indentation, and it's just simplified. This duck disposable does not implement idisposable, but it does have a dispose method. And this only works with ref struct types, because that can't implement idisposable. The error message is terrible for this, or at least was a while ago. In fact, let's see if it's still terrible. So this should now fail to compile, and it does. Yeah, and it says, enhanced using .duck disposable. Type used in a using statement must be implicitly convertible to system.idisposable. Okay, it's not. Or implement a suitable dispose method. That looks like a suitable dispose method to me. What it actually means is this isn't a ref struct. Okay, and that's not what the error message says at all. So that will be rarely useful. If you don't know what a ref struct is already, you probably don't need to know. But the ref structs that you will use all the time are span and read-only span that I mentioned earlier on. Okay, other tiny features. We now have question mark equals for the null coalescing operator, but with assignment. There's stack-alloc stuff you probably don't need to know or care about. There are static local functions. So I was discussing static methods with Fergal earlier, sorry, local methods with Fergal earlier, and we didn't go into this. There can be implications of capturing variables within a local method. And this static sort of doesn't feel like static in any other normal way, but it basically says, I can't use this and I can't capture anything. It's a sort of safety feature of, hey, I really, really need to know that this isn't going to have any nasty performance effects due to capturing. And the C# compiler is already really good about how it captures local variables and fields using local methods. It does all kinds of interesting stuff, generating structs and then passing them by reference to foo and all kinds of cool stuff. But if you happen to use them with an assignment, a conversion to a delegate type or a couple of other things, that can really kill performance. So this is a sort of safety feature. This is nice and simple to use. One of these was valid in C#7. I don't know which, I don't care. Because now I don't need to know which was valid. I think it was $at, but there was no good reason to make the compiler picky about this. Let's just say we know it wants to be verbatim, we know it wants to be interpolated, just mix and match. Finally, partly because I know I can talk about this for ages, read-only instance members. So in C#7 again, I think, we got the idea of a read-only struct. Let me find this. Right. And a read-only struct is a struct that can't have any mutable state. You can't assign to any fields after the constructor, which is generally a really good thing, just because structs are generally immutable anyway, but it has an important performance implication in a very, very specific case. So if you have a field that is read-only, only if it's a read-only field of that struct type, if you call methods on it or use properties or access any members of that, if it's not a read-only struct, then in C#7, it will take a copy of that value and then call the method or property on the copy. And it's got to because there was no way of it knowing whether that property that you were calling or the method that you were calling might change the content of the struct, which it's not allowed to do. If this is a read-only field, I want those bits to be locked in place. Nothing can modify those bits. Whereas if calling field1.getValue sneakily changed the bits, that would be bad. So it took a defensive copy, and with large-ish structs, that can make a significant performance difference. It can be so significant that in no time before read-only structs came, I had a bunch of fields that said, whoa, this would be a read-only field, but it fairly dramatically affects performance, so I will make them read-write fields and do some Roslyn checks in my unit tests to make sure I'm never writing to those fields outside the constructor. Can't remember whether I implemented those tests or not, but that was the idea. I'm delighted to say that the design doc for read-only structs actually references the blog post that I wrote about that performance tweak in Nodatime. So this is kind of my feature to some extent. So that was C#7. In C#8, you might have a struct that, suppose you have some caching mechanism. So some of your methods that need to do some expensive computation might cache a value. But other things just return the value. So we could have public public struct point, public double x and y, and public double distance from origin, and we'll make that a method because it's computing things, and we'd have a private double cached distance. I'm not going to do the implementation. This is just so that you understand what's going on. So I can't make that read-only because I would be modifying cache distance. But if I'm only accessing x and y, then I should be able to do that without taking a copy because it's safe. And in C#8, you can do that. And in fact, you would implicitly do that just because I'm using an autoprop here. The compiler decorates this property with the isReadOnly attribute, and that's what it uses when it checks whether or not it needs to make a copy. But you can put that on yourself. So we could have a getter and a setter, and we'll just do some stuff. Console.writeLine hi. And hey, this setter isn't actually changing any state. So we can actually say that the whole property is read-only. There we go. Or we could make the getter modify things, and I know that's weird, and say, the setter is read-only. Kind of bizarre, but works. There is an example if you wrap something that's a reference type. You may have a setter that is a convenience method for calling a setter on the reference, and even though you are modifying state, you're not modifying the state of that struct itself. That's still got the same bits afterwards, even though the object that it refers to you might have modified. So there can be valid reasons for having read-only on a setter. But here's a struct with a bunch of these as examples. So you can write your own property that explicitly declares it's read-only. An autoprop is implicitly read-only. And as I've shown, you can put read-only on the getter or the setter. You can't put read-only on something that's already read-only, and you can't put it on just a getter. If there's only a getter, then you've got to put it outside. A little bit like you can't put the private just on the get if there's no set. So this is really for performance reasons, but it's kind of funky and cool. Okay, there are things around unmanaged. How many of you even were aware that in C# 7.2, I think, we have a new constraint of where T-colon unmanaged? I've never used it. If you're into unsafe code, you may well use it a fair amount. But we have just about managed to race through all of the features that I'm aware of in C# 8, and I did fairly recently go over the list that was on GitHub saying, these are all the features in C# 8, and make sure I've got them in here. So we haven't gone into all of them in very much detail, certainly. Is there anything, there's still a few minutes left. No, we really do need to wrap up. While Doug is putting stuff away afterwards, if you have any questions, then come and talk to me. Otherwise, I will hand over to Doug to finish up.